started, I'd like to introduce Kaizen's own Kevin Buckner.
Thank you for that, Chelsea. I appreciate it. Welcome to my Tech to Tech, and good morning, good evening, good afternoon, wherever you are in the world. What I would like to talk about today is if you are new to electronics cleaning, this is just a few things that can help you get started with that whole process. So you want to, or really should I say you need to clean? Well, here's a few tips just to help you get started. I always like to consider the why. What is the motivation for this change? Is it a customer requirement? Has a customer come to you and said, I have all this, I would like to give you this work, but something has to change. You need to use this no clean. You need to use this rosin material set, and you don't have those capabilities, or you're not ready to go into that world yet, but you know you have to. We're here to help you with that. Could this be a liability issue? Could it be parts that have a military or an aerospace application, the type of thing when you push a button, something has to happen. There has to be a movement, if you will, an action based on what you do. Or is it a reliability issue that when you push that button, nothing happens, and that's even worse? So you're having a lot of rejects, a lot of hand rework, a lot of those type of items are coming up. This is where we are to help. So first of all, let's look at what are you really trying to clean. So we all know that it's flux and associated residues, and it's hand finger oils, it's ionics that come off hands and tools, those kind of things. But let's get specific, because not all fluxes really are created equal. What we're going to talk about in the first section, just real quick, is organic acid, which is water soluble, how most of us refer to that as water soluble. We're going to talk about rosin based, and we're going to talk about no cleans. So we talk about organic acid. So with organic acid alone, water should be good. You should be able to clean with water. But sometimes, based on population, how dense a board is, the standoff heights on the board, you may need a little help. And that's to break that water droplet size down, if you will, so we can get it underneath those devices and actually solubilize that organic acid. When we talk about rosin, we're talking about tree sap. I always refer back to my Christmas tree story that almost every one of us has had to cut down that Christmas tree. You know, you go buy it from the place, you have to freshen that root, you have to cut that trunk out, and you always get tree sap all over your hands. Well, go ahead and take that to the water and hot water and try and wash that off. Nothing happens. You need the soap to get in there and get that off of there. It clings to the sap, and then it pulls it off your hands. And then you can do the same thing with rosin flux. You are going to need chemistry, i.e. soap, to get that off of the product. So last of all, we talk about no cleans. No cleans are hydrophobic by nature. They don't like water. They actually repel water. So you are going to need some type of chemistry to get in there and clean off that no clean. No clean is actually not no residue, it's a low residue. So there are specific parts that are left on the board, but they are considered benign, and it's also less active than rosin or OA flux. So what about a machine? Have you talked about a machine? Do you have something in mind? A batch style piece of equipment, and these are terms that you'll hear when you're going into the cleaning world. Well, maybe an inline piece of equipment. Really, what's the difference between those two? Well, what are the differences? A batch style loads one basket at a time. So you're going to take all of your boards, you're going to load them into a basket, you're going to shut the door, you're going to push start, wash, rinse, and dry, all taken care of. And inline gets fed one board at a time. So if you put one board in one end of the machine, and the machine is 16, 20, 24 feet long, 16 minutes later, at 1 foot per minute, 16 minutes later, that same board comes out, and the subsequent boards come out after that. What are the differences? Well, a batch style typically runs on a vertical impingement, and the boards are located at 15 degrees. So the board is at 15 degrees, and the rotating spray arms, which actually go around, we're usually with fan style, sometimes coherent, but mostly fan style impingement devices, nozzles, if you will, push the chemistry up and down from the top and the bottom onto your board. An inline is at 90 degrees to the board surface. So the board actually will pass through, and the impingement, the spray, if you will be directly down onto the board as it passes over. Now, On inline machines, a lot of the manufacturers will do spray, then coherent, spray, then coherent. So you get a good, what they call it, intermixing of the nozzles themselves. A batch style is a wash, rinse, and dry all in the same cabinet. So once you've pushed those boards in and hit the start button, it's going to pull wash water over. It's going to, wash the boards, solubilize the flux. It's then going to use deionized water to remove all of the chemistry that's inside the chamber itself. Excuse me. And then it's going to dry inside that same chamber. An inline runs a little bit different because an inline it runs a belt through different compartments of pre-wash, wash, rinse, final rinse, and then dry, all within that same footprint. And the footprint we talk about on a batch is going to be about 3 feet by 5 feet rectangular. An inline about 5 feet deep, 16 feet, 20 feet, 24 feet. They do offer just chemistry style machines. So if you have a water inline already, you can just add a machine to the front of that, 8 foot, 6 foot, and just add chemistry into your process. What about water? DI or city water? I get asked this all the time. Remember this statement. Your boards are only as clean as the last rinse that touched them, the last thing that touched them. City water is going to supply you with ionics, calciums, and salts. We're trying to get rid of all of those. That's what the idea behind washing is, so you have no dendritic growth or any type of problem. If you remove all of that in the wash and then you rinse without deionized water, you're doing the same thing. You're reintroducing all of that back into the process. So what about clean? What is clean to you and your customer? You have to decide that. I mean, people ask me all the time, Kevin, what do you think clean is? And I'll tell you, clean is absolute zero. But you have to think, in this world, is absolute zero really attainable? You have to decide, can I get away with cleaning this down to a certain tolerance? And really, the old standards don't apply in today's world. If you look about some standards that were written back in the 70s, a standard 10 micrograms of sodium equivalency would be a pass. Now, that may not be your definition, but it could be, because that's actually a written definition of what clean is. Here's where I have a slight problem with that. If you take a look at this simple rudimentary drawing of a board, that's the blue outline, and the single component that we have up in the upper left-hand corner, if we were to run this through an old testing protocol, this board would pass. It would be 9.99 micrograms of sodium equivalents laying underneath that component. But therein lies the problem. All of that contamination is directly underneath that component. And that's where you can get a problem with a failure. This is a pretty simple line drawing of a double-sided mixed assembly workflow. It's the solder paste printing, the SMD parts, it's the reflow, the flipping, the component placing, the pasting, the printing, the soldering, everything in there. What's the one thing you don't see in there? You don't see cleaning. Cleaning is often the stepchild. We're thought about afterwards in the process. We're never really considered when plans of PCB production are talked about. The cleaning process is not often considered during this. And I think in the world that we live in today, maybe it should be. Thank you so much for joining me for my Tech to Tech. I'm going to turn it back to Chelsea.
Thank you, Kevin. If you would like to discuss this topic further, please contact your local Kaizen representative or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.
Thank you so much.